Thank you. All right, so today we're going to be doing 4-8, which is solving radical equations. So radicals are, roots, square roots, cube roots, fourth roots, all of that stuff. So that's what we're going to be solving today, equations involving them. So there's 4 important rules or steps that you need to know in order to do this. The first step is to isolate the most complicated radical on one side of the equation. The next step will be to raise each side to a power equal to the radical's index. So a radical's index is that little number that's in the little V shape on the outside of the radical. Now if your radical is a square root, it's not going to have any number there. It's going to be an implied 2. You're going to solve the resulting polynomial and check for extraneous solutions. So can anybody remind me what an extraneous solution is in math? Good, yeah. It's a solution that comes out mathematically when you do the question correctly, but it's either it doesn't work when you plug it back in or it doesn't work in the context of the problem. So, good job. So, let's go ahead and do an example. I think you're the first person that's probably answered that today, so thank you. Star student. All right. So the first thing we're going to do in example 1 is we need to get our radical by itself. Okay? Our goal is to always get the radical by itself if we only have one radical. So what can I do to get the radical by itself?
Subtract 5.
Good. I'm going to subtract 5 on both sides. And when I do that, that's going to leave me with radical 3x plus 4 is equal to 5. And then once you get to that stage, you need to get rid of the radical. So how do we reverse a square root? Good, we square it. But if I square one side, I also need to. Very good, square the other. The radical and the square cancel each other out. So I'm just left with 3x plus 4 is equal to what? Good, 25. I subtract 4 on both sides, which leaves me with 3x is equal to 21. And then I just divide by 3, and I get x equals 7. So x equals 7 is what we call our proposed solution, because we don't know if it's a solution yet until we plug it back in to confirm it, because it could be an extraneous solution. So that's one of the most important things in this topic that we need to address. So I'm going to rewrite my equation, but I'm just going to replace my x with my proposed solution, which is 7. And I'm just going to confirm and see that this is a true statement when I do it. Now, typically, I don't show the work for all those steps. I kind of just do it in my head. So, what is 3 times 7?
21.
Good. 21 plus 4? Good. What's the square root of 25? Good. And is 5 plus 5 equal to 10?
Yeah.
Yes. So we can say this is a confirmed solution now, because we've checked it by plugging it back into the equation. Let's go ahead and try example number 2. So example number 2 is similar. We have one radical, so we need to get everything else to the other side. So what should I do?
Add 5.
Very good. We're going to add 5. We get radical 4x plus 1 is equal to 5. What are we going to do then? Not square root, but good. We're going to square both sides. These cancel, and I'm left with 4x plus 1 equals 25. Subtract 1 on both sides. 4x equals 24, which means x equals 6. Now, to confirm my answer, I go ahead and I plug 6 back in for x to see if it's a true answer or not. So I just replace x with 6. So 4 times 6 is 24. 24 plus 1 is 25. Square root of 25 is 5. 5 minus 5 is 0. So yes, this is a solution. So these two are the most straightforward case you're going to see with radical equation. We're going to do a few that have a little more in-depth solutions and whatnot. But does anybody have any questions about the linear ones, 1 and 2? All right, so let's go ahead and move into the quadratic ones. So what's going to happen in these cases is your answer, you're going to have to use factoring quadratics to get it. It's not really hard or anything. It's just that they're going to be a little bit different. So the first thing we need to do here is to get our radical by itself. So what should we do? Good. We're going to add 5. I'm going to be left with radical x plus 7 is equal to x plus 5. And then I need to do what to both sides?
Square root.
Not square root, but square it. That gives me x plus 7 is equal to. And if I want to square a binomial, I need to write that binomial out twice, right?
Yeah.
And then I need to do either FOIL or box method to multiply it out. So I'm going to use FOIL, but if you want, you can use box method as well. So I'm going to FOIL this, and I'm just going to bring down everything on the left side. X times x is x squared. X times 5 is 5x. 5 times x is 5x. And then lastly, 5 times 5 is 25. Now at this stage, you need to combine any like terms that occur. So as you can see, we can add those two 5x's together. And now we have a situation where we can see that this is quadratic. So when you see that you're getting a quadratic because you have an x squared, what I want you to do at this stage is to get everything to one side of the equation when this happens. So to do that, I'm going to subtract over the x, and I'm also going to subtract over the 7. So these are both going to cancel and leave me with 0 equals x squared plus 9x plus 18. So anytime that you're going to get to a situation where you're trying to factor a quadratic, you always want it to be equal to 0, okay, when you want to factor a quadratic. So your goal is to get it equal to 0. So at this stage, you should be at a point where your quadratic can actually factor. So we're looking for factors of 18 that add up to 9. What do you think? Good. 6 plus 3 is 9, but 6 times 3 is 18, which we want. And then we're going to set each of these equal to what? 0. Good. We're going to set them equal to 0, and then you should be able to solve to get two solutions here. Now, they're not necessarily solutions, but they're, possible solutions. So I get x equals -6. That's a negative. I just drew it poorly. And then this is x equals -3. So now that we have those two solutions, what do I need to do with them? Yeah, I got to plug them back in, right? So I'm going to plug in the -6. So that's -6 plus 7 minus 5 equals -6. So what's -6 plus 7? 1. What's the square root of 1? 1. What's 1 minus 5? -4. So is this a solution? No. This one's actually rejected. Now let's try -3 to see if we have better luck. So we have -3 plus 7 minus 5 equals -3. So -3 plus 7 is good. 4 minus, so square root of 4 minus 5. Square root of 4 is good. 2 minus 5 is -3. What do you think? True or false? True. Good. So this is a true statement. Make sense so far to everybody? Okay. Let's go ahead and try another one of these. Alright, so same thing over here. We're going to try to get the radical by itself. I'm going to subtract 3 on both sides. That gives me the square root of 5x minus 1 equals x minus 3. I'm going to square both sides, which cancels out my square root. and leaves me with 5x minus 1 equals x minus 3 times x minus 3. I'm going to FOIL over here, which gives me x squared minus 3x minus 3x plus 9. Combine like terms. That gives me x squared minus 6x plus 9. Subtract 5x to both sides. Add 1. So I'm just basically getting everything to the right side to get it equal to 0. That gives me 0 equals x squared minus 11x plus 10. Everybody see how I got to that point? And then I'm looking for factors of 10 that add up to negative 11. What do you guys think? Yes, negative 10 and negative 1. So then I'm going to set each. You get it? Okay. So then we're going to set each of these equal to 0. We get x equals 10. And this one would yield us x equals 1 when we set it equal to 0. Everybody good on how I got 10 and 1 as my solutions? And then since we know our solutions are 10 and 1, we can plug those back into my original equation. So we'll go back up here and we're going to plug them in. So the square root of 5 times 10 minus 1 plus 3 is equal to 10. So 5 times 10 is 50. 50 minus 1 is 49. Square root of 49 is 7. 7 plus 3 is 10. So that one is a solution. So then we'll see about the other one, which was 1, I believe. Yeah. So we do 5 times 1 minus 1 plus 3 equals 1. Well, 5 times 1 is 5. And then 5 minus 1 is 4. Square root of 4 is 2. No, this one doesn't work out. So the last one is not a solution because it doesn't it doesn't make a true statement when you plug it back in. So any questions about this one? Everybody understand these two? All right, so now we're going to go into the two types of problems that are kind of more unique solving methods. So let's go ahead and do number 5. So number 5 is going to be long, so I just want to warn you, so if you want to leave yourself a little more space or write smaller, it is going to be a longer problem. And if you do this kind of problem in the future, you can kind of condense some of the steps, but I'm just doing it the long way because I want you to see every step so you can kind of understand what I'm doing because you're learning it for the first time. So on this problem, example 5, what do you notice is different about this problem than the others?
Square root on both sides.
Well, yeah, there's 2 square roots, right? We don't have just 1 square root like before. So when this happens where you have 2 square roots, you want to get both of those square roots to the same side if they're equal to, if there's a number over here, okay? And the way we actually have to go about doing this is there's actually a few options. So, let's see. Somewhere. So in this case, if I add this square root of x to both sides here, I will get x minus 12 is equal to 2 plus the square root of x. And then now I have the square roots on opposite sides, but I can square both sides, right? So I go ahead and I square both sides. And what happens on the left is simple. This just becomes x minus 12. But over here, this one I'm actually going to have to write out because I'm going to have to do FOIL on it. Yeah, I think this is a lot faster than the way I did it earlier. I still got the same answer, but so then we're gonna FOIL that. So first times first, outer times outer, inner times inner, last times last. What's the square root of x times the square root of x? Good, x. So then over here, I should be able to simplify. So I'm left with 4 plus 4x, or 4 radical x plus x. So everybody see how we got to this point. So, okay. So then now I'm going to subtract x on both sides, and what do you notice happens to the x's? Yeah, they cancel out. So I'm left with just this. And now your goal is to get the radical by itself again. So subtract 4. That gives me negative 16 equals 4 times radical x. Divide both sides by 4. And you get square root of x is equal to negative 4. Now, before you go about squaring both sides, what do you notice is the problem here? Like, why can't I just square both sides and be done with it? There's a red flag at this question. Anybody know what it is? Can I take the square root of something and obtain a negative number? No. So what do you think this answer is to this question? Good, no solution. So there are several ways to go about doing this problem. Earlier we did it a little bit differently. Either way, we got no solution. So sometimes there's a way that you can do this problem where you actually get an answer, but when you plug it back in, it rejects. It doesn't work. So there are kind of several different ways to go about this problem, but in the end, you're always going to get the same answer of no solution. So does that one make sense? Okay. So the last one is actually pretty straightforward. So for the last question, when you have a radical on both sides like this, and that's all you have, you're just going to square both sides. And you get the radicals just go away. And then you just solve it. So we get x minus 7 equals 2. Add 7 to both sides, which just gives me x equals 9. So pretty straightforward. And then we just plug the x back in to ensure that's a true statement. So 2 times 9 minus 7 is equal to 9 plus 2. So that's the square root of 11 equals the square root of 11. True or false? True. So this is an answer. So that's the whole lesson.